You've probably watched or played basketball where free throws were involved. Have you ever thought about the biomechanics behind it? First, the players align themselves with the free throw line and set up their stance with their feet a shoulder width apart. Then players execute a process referred to as beef in which they first balance themselves, center their eyes on the target, flex their elbow to a 90-degree angle while knees are slightly bent, and finish with a follow through. After the players follow these steps and the ball is released, the ideal result is a made free throw. With this video, we hope to demonstrate some of the biomechanical principles behind this movement.
Before you can truly understand the larger principles, you have to understand the smaller components that will make up the movement as a whole. Muscles work together to produce a movement, with each muscle playing a different part. Agonists are the primary movers that contract and cause movement. In the free throws follow-through stage, the triceps and wrist flexors are the agonists. Antagonists do the exact opposite by opposing that movement. In the free throws follow-through stage, biceps and wrist extensors play this part. Stabilizers immobilize joints while the agonists are moving to provide support. For this movement, the stabilizers include the rotator cuff and scapular muscles. Lastly, neutralizers prevent unwanted accessory actions by antagonists. For the follow-through free throw, this includes the posterior deltoid, infraspinatus, and latissimus dorsi muscles. The base of support is defined as an area enclosed by outermost edges in contact with a supporting surface. This is important to a free throw to ensure stability, which ensures precision to make the basket. Without stability, the player would be recruiting other muscle groups in order to not fall, instead of focusing on the ones required for free throws. Usually the base of support is a shoulder's width apart, as demonstrated. However, to show how important a proper base of support is, we will challenge a typical stance. Our base of support test will have both our injured novice and experienced player try to make a free throw while standing on one foot. This experiment greatly reduces the base of support and reduces stability. In contrast, having a staggered stance will improve stability as the base of support is expanded. Center of mass is defined as the point around which a body's mass is equally balanced in all directions. While performing a free throw, the players have to have a stable center of mass located in the abdomen. Changing one's center of mass to be outside the base of support will negatively affect the outcome of the free throw, as the resulting instability can cause the players to miss the basket. To demonstrate this, our center of mass test will challenge both the horizontal and vertical positions. In the horizontal center of mass test, our players will lean far enough forward so that the center of mass is close to the boundary of the base of support. Now to test the vertical center of mass, our players will lay down and attempt to make the basket. Senses are the ways that our brains acquire knowledge about the outside world and within ourselves. The two most important when related to sports are vision and proprioception. Vision is a sense that detects information outside of the body. To test vision's importance, we'll be demonstrating multiple ways to mess with our player's vision. First, the base test without any challenges. Next, with eyes closed. Next, a test with one eye covered. Finally, we'll test their vision in dim light, which will only stimulate the rock in their eyes. Proprioception is defined as the sense that detects information inside the body, including body position and movement. Although we do not have the technology needed to manipulate proprioception with muscle tendon vibration or electrical stimulation, our test will manipulate the vestibular system. This will be accomplished by having the players spin around 10 times in succession to disrupt the fluids in the semicircular canals, which help you balance. In conclusion, each of these principles plays a significant role in successfully making a free throw shot. First, we discuss the muscle mechanics of the movement, emphasizing the follow-through. The most important muscles in the follow-through stage of the free throw are the agonists, which are the triceps and wrist flexors. Next, we talk about the factors affecting stability, which are base of support and center of mass. These are important because proper balance allows for players to focus their muscle groups on the movement instead of preventing falls. Finally, we talked about the two senses most important to performance, which are vision and proprioception. Vision is one of the most important human senses and is crucial to aiming the free throw, and proprioception helps coordinate where you are in space in relation to the basket. We hope you learned a little about biomechanics and how to make a free throw, so next time you're watching or playing basketball, you will understand the movements.